My topic is on Alzheimer's disease and the biological mechanisms of memory loss. So, in researching this topic, my goal was to understand how Alzheimer's disease alters the biological composition of the brain to result in memory loss. For the research method, I explored fMRI because it can help pinpoint what region of the brain Alzheimer's degrades and how it affects tissue there. I'll be analyzing Alzheimer's biological implications from three different approaches: systems or networks, neuroanatomical, and cellular. So for the research method portion of the project, decided to choose functional MRIs because they're usually the most precise in identifying structural changes related to Alzheimer's disease. By using temporal data, fMRIs can determine where neural networks are degenerating and how they progress over time. For the first approach, um, I saw that the accumulation of tau in the hippocampus is associated with memory loss in patients with Alzheimer's. However, damage does not occur uniformly. It is scattered and it occurs at different levels thanks to the organization of the hippocampal formation. Most of this accumulation starts in the entorhinal cortex, which is connected to the hippocampus by two layers of circuits. In support of this finding, neurons are affected differently depending on which circuit they belong to, with some degenerating while others remaining healthy. For the neuroanatomical approach, gray matter volume in the hippocampus declines rapidly, which is typically associated with the loss in memory formation and language skills. Neurons that lack sufficient myeliniation typically degenerate first, with those highly manipulated lasting until the most developed forms of Alzheimer's. This is why the prefrontal and parietal lobes are particularly vulnerable in the development of the disease, as insufficient levels of myeliniation force neurons to use more energy. And then finally, I use the cellular approach. As mentioned earlier, the accumulation of tau is believed to be a primary cause of Alzheimer's disease. More specifically, it grows around dendrites and decreases the effectiveness of postsynaptic function. When tau is acylated, it can block signaling from postsynaptic functions and promote memory loss.